All right, today we're going to crack open the engine of the internet and take a look at two of its most critical workers, TCP and UDP. These are the digital messengers that pretty much make everything you do online actually possible. You know how it is, right? You're on a video call, and for a second, the image gets all blocky and weird, but then it just catches up, and everything's fine. But think about this. Have you ever gotten an email where, like, half the words are just missing? Of course not. It's either the whole thing or it's nothing at all. So what's the deal with that? Well, the answer comes down to the messenger. Seriously, the internet picks a specific type of digital messenger to deliver your information, and these two messengers have completely different personalities and, more importantly, different priorities. Okay, so let's properly meet our two messengers. We're talking about two fundamental protocols, and they are built for totally different jobs. So on one side, you've got TCP. This is the reliable one. Think of a super careful delivery service that tracks every package, needs a signature, and absolutely guarantees a perfect delivery. Then, on the other side, there's a UDP, the fast one. This is more like the person who just flings the newspaper onto your porch. It gets there really fast, yeah, but they aren't sticking around to see if it landed in a puddle. So let's dig into TCP first, our meticulous, reliable messenger. Its whole mission in life is to make sure your data gets from point A to point B without a single tiny error. The formal name is Transmission Control Protocol, and the key phrase here is connection-oriented. What that really means is that it sets up a stable, dedicated connection before it even sends the first piece of data. It's basically making sure you're on the line and ready to listen before it starts talking. And this is how it kicks off that connection. It's a clever little process called the three-way handshake. It's almost exactly like calling ahead. The sender pings the receiver saying, "Hey, I've got something for you." That's the SYN. The receiver answers back, "Okay, I hear you. I'm ready to go." That's the SYN-ACK. And finally, the sender says, "Great, it's coming your way." That's the ACK. Only after everyone has agreed does the actual data start to move. So how does it stay so reliable? Well, TCP breaks your data into little packets and gives every single one a number, just like page numbers in a book. As the receiver gets each packet, it sends back a little "got it" message, an acknowledgement. Think of them as delivery receipts. If the sender doesn't get a receipt back for, say, page 5, it just sends page 5 again. It's even smart enough to slow down if it thinks it's sending too much too fast. But you knew there had to be a catch, right? All this careful work comes at a cost. The pros are amazing. You get perfect ordered data every time. But the con is speed. That handshake and all the back and forth acknowledgements add time. We call that latency. And what's worse, if a single packet gets lost, the whole operation grinds to a halt and waits for that one packet to be resent. It's a real bottleneck. So, if TCP's reliability can sometimes be a drag, what's the alternative? Well, it's time to meet our other messenger, UDP. And for UDP, the number one priority isn't perfection, it's just pure, raw speed. UDP stands for User Datagram Protocol. And yeah, its definition is basically the polar opposite of TCP's. It's connectionless. That means no handshake, no setup call, it just goes. It's all about speed over guarantees. Honestly, the best way to think about it is fire and forget. UDP takes your data, slaps an address on it, and just shoots it out into the network. It doesn't check if anyone is ready for it, it doesn't wait for a thank you, it just sends and hopes for the best. And the trade-offs here are just as clear. The massive pro is speed. We're talking very low latency because there's none of that extra baggage. But the con, well, there are no guarantees whatsoever. Packets can get lost, they can show up in the wrong order, and UDP itself does absolutely nothing to fix it. It's not its job. And this brings us right to the central conflict at the very heart of how the internet works. It's this constant battle, this fundamental design choice between being absolutely reliable and being as fast as possible. So naturally, you're probably thinking, okay, after all that, which one is actually better? And the answer is, that's kind of the wrong question. One isn't just better than the other. It's all about picking the right tool for the job. You wouldn't use a sledgehammer to hang a picture, right? Same idea. This table just lays it out perfectly. You need guaranteed reliability and your data in the right order, you gotta use TCP. You need the lowest possible latency and you can handle a little imperfection. That's UDP's specialty. You can see how they're just direct opposites on almost every single point. Okay, enough with the theory. Let's make this concrete and see how this choice plays out in the apps and services you actually use every single day. Okay, Think about loading a website or downloading a file. You need every single byte of that data. If just one little piece of code is missing from a web page, the whole thing could break. If a few pixels are gone from an image, it's corrupted. There is zero room for error. This is a job for TCP, the reliable one, no question. But now, let's go back to that video call or your favorite online game. Here, what matters most is what's happening right now. It is way, way better to have a single dropped frame of video, that little glitchy moment, than for the entire game to freeze for 2 seconds waiting for a lost packet to be resent. That would be infuriating. So for this, you absolutely want UDP, the fast one. Here's another great example you might not think about. DNS. That's the internet's phone book. It's the system that turns a website name into a numerical IP address. It's a tiny question and a tiny answer. Using TCP's whole formal handshake for that would be like sending a certified letter just to ask what time it is. Total overkill. UDP handles it almost instantly, which is a huge reason the web feels so responsive. So this fundamental choice between TCP and UDP has defined the internet for decades. But as our needs get more and more complex, engineers are starting to ask, what's next? So look, if you take one thing away from this explainer, it's this. For the longest time, the internet was built on a fundamental choice. You want it perfect, or you want it now. You had to pick a path, the reliable road with TCP or the fast lane with UDP. You couldn't have both. But what if you didn't have to choose? What if you could build a system that had the raw speed of UDP, but then you added the reliability on top of it? Well, that's exactly the idea behind new protocols like QUIC, which powers a huge chunk of the modern web. It's trying to give us the best of both worlds, and it's completely changing the game. Something to think about.